Guys, welcome back to TechDose, and in this video we will look at minimum time to visit a cell in a grid problem, which is from Leetcode number 2577. A prerequisite before watching this is to watch my video on the Dijkstra algorithm, which is single source shortest path. A very similar problem that you can solve is find minimum time to reach last room 1 and 2 problem. I have already made a video on both of these, so you can click on the I button and also find the link in the description below. This problem is from Leetcode number 3341 and 3342. Now let's read the problem statement. In this problem, you are given an m by n matrix grid consisting of the non-negative integers, where grid at row column represents the minimum time required to be able to visit that cell row comma column, which means you can visit the cell row comma column only when the time you visit it is greater than or equal to grid at row column. You are standing in the top left cell of the matrix and the 0th second, and you must move to any adjacent cell in all the 4 directions, that means up, right, down, left. Each move you make takes 1 second from one cell to the adjacent cell. Return the minimum time required in which you can visit the bottom right cell of the matrix. If you cannot visit the bottom right cell, then we need to return -1. Before looking at any example, let's look at the constraint. In the constraint section, you will find m as the number of rows, n as the number of columns, and you will find that the number of cells, total number of cells, will not be more than 10 to the power of 5, and each of the value is also within the integer range, and the start point will always be 0. That means grid at 0, 0 is always 0. So it is always possible to get to the start point at time t equals to 0, right? Now let's look at an example for better understanding. In this case, let's assume that this is our example number 1. Okay, so an m by n matrix will be given. In this case, I am just taking a 3 by 3 matrix. We need to find the minimum time to reach the m-1 n-1th cell from the 0 0 cell. That means the 0 0 is the top left cell, so this will be the start point. Okay, and you want to reach to the bottom right cell. This is your m-1 n-1th cell, right? So in this case, we want to find out the minimum time to reach from the top left to bottom right, and each of the jump will cost you a +1 in terms of time, right? There are certain constraints to it. The first constraint is we can make 4 directional adjacent movement. It is allowed, and we can make the calls in all the 4 directions, up, right, down, left, and we must move each second to any adjacent cell. You cannot wait on a cell. Okay, we have to always be on the move. Now if you clearly look at this problem, they are asking to reach from a start point to end point and find out the minimum cost to reach to the end point. This is the same as starting from the source node or a source position and getting to the destination position with some associated cost of jumping, and this is the same as your single source shortest path, right, which is your Dijkstra's algorithm, and that's why I told you to watch that video again. Now in my previous video, I have clearly explained all these things, like how the Dijkstra is implemented, how it works, and all those things. So this is the same problem. I hope you have understood that. Now in this particular example, you can see that I will start with the start node, let's say at 0 0 at time t equals to 0. So let's say my current time t is equals to 0. At this point, can I make the jump to 0 comma 1? Well, it will not be possible because this time here is 2. This means that if our current time is greater than equals to 2, then only I can reach to this 2. My current time is 0. If I try to reach to the next cell to the right hand side, I will get +1 time due to jumping, and so my time here will be t equals to 1. But the time of the cell is saying 2. That means minimum time should be 2, so I cannot make this jump actually. If you try to move up and left, these are out of bounds. If you try to move down, then you cannot move down here, because again for the same reason, here your time was 0. If you do +1 to it, you will reach to row number 1, column number 0, time equals to 1. But this requirement says you must have time greater than equals to 2 when you reach to this cell, so you cannot make this call again. So from this 0 0, you could not move anywhere, and since the constraint says that you must move each second, okay, to any of the adjacent cell, you cannot wait at any cell. So for that reason, it is not possible to travel from the start point to the end point, and therefore I will be returning a -1 value saying that it is not possible. Fine. So this was example 1. Let's look at example number 2. In this case, if you start at the starting point, let's say this 0 comma 0, from here you cannot make a right call right in the beginning, but then you can always make a down call and go to this one. From this one, now here the time is equals to 1, right? Now you cannot make a call down from here, right? because the time will be equals to 2, but the requirement is saying it is 4. So what you can do is you can reuse the cell 0 0 and you can reach back to this 0 again, and your time will increase to 2. So what you did was you moved from 0 to 1 and again from 1 to 0, and your time is now 2. Now if you think about traveling from this 0 0, you can travel to the right side and you can also travel down back again, isn't it? So if you travel to the right, then your time here will be equals to 3, and this is perfectly fine. If you move down, then the time here will be 3, and this is perfectly fine. You can independently do this traversal. From this 2, can you move to the right? It will not be possible, because 3 plus 1 is 4 and this is 5. So we cannot make this traversal happen. So we will check if I can move down. No, again for the same reason, you cannot move up because that will be out of bound. So again we will move back from this 2, and here the time will be equals to 4, right? Now from here at time equals to 3, we can make a call. At time equals to 4, we will be reaching here, so we will make this call, right? So I am leaving out this trail and we will be following this, because from here at time equals to 5, you will be reaching to this 3, and at time equals to 6, you will be reaching to this 4. So since we can reach to 4 at time t equals to 6, following a trail of 0 1 0 1 4 3 4, this is my trail, or you can say the walk or the path, right? So using this, I reach to the bottom right corner, and hence the answer is 6 in this case. Fine. Now if you look at the third example here, again I will be starting at the top left corner, and from here I can try out all the possibilities. So I cannot make the right call because 0 plus 1 will be 1 and this value is 2. So I cannot make this call. I can move down, and here the time will be equals to 1. From here I cannot move down, but I can move right at time t equals to 2, right? From this 0, I can always move up because I was not able to move up previously. So I can move here at time t equals to 3. Can I move to the right? No. Can I move down? Yes, at time t equals to 3. Now from here as well, you can move to the right. No, you cannot move to the right, isn't it? You can move back and you can move down. But I'm leaving this out because this will not contribute to our optimal solution anyway. I'm just showing you visually how it is working. So from this 3, I can make a call here at time t equals to 4, and I can also make a call here at time t equals to 4. So I was able to reach to the bottom right corner from the top left at time t equals to 4, having started at 0 0 at time t equals to 0, where each jump actually took me 1 cost. So the answer in this case will be 4. So I hope the problem statement is clear, and now let's look at some observation to help solve our problem optimally. Now if you look at an example here, a 3 by 3 matrix again, then you know what, whenever you are not able to cross the barrier, like let's say that I had started at this 0 and I went to this 1. So I had started at time t equals to 0, I went to this 1 at time t equals to 1, because a plus 1 cost will be added, and this is completely fine. But when from here, if you want to cross the barrier, like let's say you want to cross this barrier of 8, then at what time will you be able to cross it, and what will be the optimal solution? Now if you think about a general case, let's take a general example where I want to go from this 3 to 8. Well, how can you move here, and how did we even reach to this 3? Like let's say that I started at this 0 and went to 1, so my time t was equals to 1. Then again from 1 I cannot directly jump to this 3 because time will be 2, and this requirement says my time should be greater than equals to 3. So I'll again go back to 0 and my time will be 2 here, and again I will come back, and here the time will now be 3. So from here if I reach to this 3, my time will be equals to, let's say, 4. Okay, so I reach to this index having the value 3 at time t equals to 4. Now I want to cross this barrier and reach to this 8. So I cannot directly jump over, because if I jump over, then my time will be 5, and this time is saying it should be 8. So what I should do is, I have multiple choice. Either I want to go up, right, and then down, that is one choice, or I can waste time by moving back and forth, So when you go back from this 3 to 1, then you can again come back to this 3, again go back to 1, and again come back to 3. This back and forth movement will only be allowed if this 3 is not at index 0, 0. Because if this was at index 0, 0, then that was actually your start point and there is no previous node. But if this is any node I, j which is not equals to your 0, 0, then in that case you always have a previous node through which you reach to this point, right? So you can always move back and forth for that. So in this case, I can do a wastage of time by moving back and forth. This is one idea, that if my time is 4, I can move back and my time will be 5 here, and again I can move forward and my time will be 6 here, again I will move back and my time will be 7, again I will move forward and my time will be 8, and now if I make a jump, then my time to reach here is 9, which is greater than equals to 8, so I can move here, right? Okay, this is one option, but this will always be optimal. We have to prove that this is always optimal. Now you can fill any values for this x and y. Okay, now let's say that your time t was equals to 4. So let's say you filled a value 5 here and a value 6 here. So you can fill any value 2, 1, 2, and whatever you want. So from this 3, I can reach to this point x at time t equals to 5. From here I can reach to this y at time t equals to 6. But then again I cannot reach to this 8 again, right? So I have to waste more time. Okay, so for that reason I will go back to x and again come back. If you go back to x, your time will be 6 plus 1, 7, and if you again come back, it will be t equals to 8. So now if you move from this y, it will be again t equals to 9. This is the best case scenario that you can get, moving up to x and moving to y and again coming back to 8. Because what is happening is, if you have a current node and if you want to reach to a target node, just the adjacent target node, then the amount of time you are wasting by going back and coming to the current node is plus 2. Plus 1 for going back, plus 1 for coming again. The amount of time you waste into going up and right is also 2. Plus 1 and plus 1, provided you can travel there, right? So either you be at this y and try to move down, or either you be at the same current cell and try to move to the right. You can add plus 2, and you cannot improve the solution if you go to x and y and then again go to target. Okay, it is not possible at all. So that is why, if I already know that it will not be possible, so why not just move back and forth and just waste our time? Okay, even you don't have to move this back and forth. You can directly calculate how much time will be required, because you know that the back and forth pattern will be same every time you make a jump. So every time you want to make a circular jump from 3 again coming back to 3, it will be a plus 2 size. Okay, so let's say the gap between this 3 and 8, what is the gap? The current timer is 4. The timer which I need is 8. So what is the gap? The gap is equals to 8 minus 4, which is 4. Okay, so I need to waste at least 3 amount of time by moving back and forth, right? By moving back and forth. So how many times back and forth do I require to waste 3 amount of time? I don't want to waste 4 units, because one time will be taken to make the jump. So for making a wastage of 3, you need to make 3 by 2. That means these many jumps, and take the seal of it. That means you want to make 2 times back and forth movement. So if you make 2 times back and forth movement, the equivalent time that you will be adding is 2 times of 2. That means 4 will be added here, and this will be 8. So again at time 8, you will come back to this same index which is present at 3, and now you will be ready to make the jump. This is the case when both the timers were even. When the time at which you are at the adjacent cell is even and the next cell is also even. I mean, not just even, but the gap is even. Okay, they may be both odd or they may be both even. The gap is always even in that case, right? Even minus even is even, and odd minus odd is also even, right? So in this case, 4 and 8's difference will be even. Even if it was 3 and 7, it would be even, right? So this is the calculation. But what if, let's say the timer here was somehow, let's say t equals to 3 and this was 8. Then in order to calculate it again, what you have to do, you have to find the gap. So the gap will be equals to 8 minus 3, which is 5 minus 1. Okay, 5 minus 1, because if you want to cover up this gap of 5, then what you need to do is simply you have to cover up this time of 4, not 5, because one time will be consumed in making the jump to the adjacent cell, right? So 4 gap can be actually covered in 2 times to and fro motion, right? 2 times to and fro motion, and that I can easily do by adding this value 4 to our timer, to our current timer. So add a value 4 here, so this will become 7, and so I will be just adding a plus 1 value and I will assign the current value itself, which is 8, right? So in short, if you have a 3 and if you want to go to the next cell, which is let's say 8, then I will see what is the current timer. Let's say the current timer is 4, then I will check what is the difference. It is an even number, right? 8 minus 4 is an even number. So you just take the gap, what is the gap, and you add 1 value to it. What is the gap? 8 minus 4 is 4. So 4 is the gap. So this much time will definitely be wasted by moving back and forth. So you add 4 to this, it will be 8, and then add plus 1, because one time will be taken to make the jump. But if you wanted to make this jump from 3 to 8, and let's say the current timer was 5, so in that case the gap between this t and the next cell is an odd number, and in that case you can just take the gap, which is 3, and then you can just add this value to this 5 and make it 8, and say that at 8 time I will be reaching this next cell. I don't have to add plus 1, because since it is an odd number, if I move back and forth, all the even count will be getting out, and then lastly a 1 will be left. Any odd number can be decomposed in the sum of 2, 2, 2, 2 and so on, so that the last number is a 1, right? So you can decompose all these 2, 2, 2 by moving back and forth, back and forth, back and forth, and then finally you can add a plus 1 value to make the jump. Okay, so this is the observation, and this is a very important observation to solve this problem. Once you have understood this, then let's look at the next observation. In this case, if I have to start at 0, 0, then a blocking can only happen at the index 0, 0. It is not possible to block at any other index. Like let's say you are present at 0, 0. If you cannot make a jump to either right and down, then you will always return -1, because there is no previous node where you can move back and forth and so on, right? And pass time. That is not possible. But if you can move to any cell and reach to any cell except for 0, 0, then there is no way that you can actually get blocked. So I have made another example. In this case, if you reach to 1, which is not a 0, 0 cell, right? Then you cannot be blocked now, because you can always move to this 0, and even if you had started at time t equals to 0, you move to 1 at time t equals to 1, you can keep moving back and forth. Here time t equals to 2, again you move forward and increase the time, again you move backward and increase the time to 4, and again you move forward and you make it 5. You will keep on wasting time until the adjacent cell is actually sufficing your current timer, and then you can move to the next cell, isn't it? When you reach to a value 7 or greater than 7, then you can make the jump to either of these cells. It is always possible, right? So the point here is blocking can only happen at index 0, 0, otherwise it will never happen. So let's look at the Dijkstra algorithm dry run and try to understand how to solve this problem. So I have taken an example. So this is the given matrix from where I will be traversing from the top left. This is my source, and I will be trying to go to the bottom right. This is my destination. Now I'll be taking a visited array of the same size m by n and marking them all false, saying that it is not visited. Now in this case, since I want to find out the minimum cost path, therefore I want to greedily decide on what is the next best possible minimum cost option, right? So for that reason I want a min heap, because I always want to pick up the next cell with the min cost. So what is the cost here? The cost is based on time. So I have to decide on time, and also whenever I decide on time, I have to know the location of the node for which I am talking about. So I should save the coordinate as well. Okay. Now before processing, the first thing I have to check is it even possible to reach from the source to destination? So what I said in the observation was if you get blocked at 0, 0, then it will not be possible. But if you are not blocked at 0, 0, it will always be possible. So check if you are blocked at 0, 0. How to check that? In these two directions, you have to see if you can make a jump. If you had started at time t equals to 0, you cannot make a jump to the right side, but you can make a jump to the bottom side, right? You can always make this jump. So it is a non-blocking type example which I am giving. Okay. So that is why we will be proceeding with the algorithm. In this algorithm, we will be defining a min heap first, and then we will be inserting what is the current time, that means 0, and the coordinate 0, 0. Now since I am inserting this 0, 0, I will be making it as true, that means it is visited. And now I will start our while loop until the min heap is empty or we have reached to our destination node, right? So from here again I will be trying to make all the 4 directional calls. I cannot make a call to the upside because it is out of bound. If you want to make a call to the right hand side, yes, you can make it, but then you have to waste time. How much time needs to be wasted? You need to go here to 1 and then come back to 0 again. So 2 units of time will be wasted, and then only you will be able to reach this 2. So you can calculate what is the current timer 0, what is the time required, it is minimum 2. So what is the gap? It is 2, right? It is even number. So check the even number, you add it and then add +1 to it, because if it is even, then you will be wasting even time by going to and making the back and forth movement, and then +1 for making the jump. So the new time that will be added is time t equals to 3 and then 0 comma 1. I hope you have understood why it is not 2, because at 0 you will go here plus 1 and you will again come back to 0 plus 1 again for that. So time will be 2 and then I will make this jump and go to 0 comma 1, right? So this is how this is 3 comma 0 comma 1. Now since this node is inserted, I will be marking it as true. Now I'll try to see if I can move down. Yes, you can move down, right? So the time will be 0 plus whatever it is 1, right? So it will be equals to time equals to 1. And here you will be just appending at time 1 I reach to 1 comma 0. So by the way, whenever you start processing this, you have to always remove the top of the min heap and then only you can start processing, right? So I had already removed this 0 0 0 and that's how I know what is the cost and index and all those things, right? So after having done this, we have processed the coordinate 0 0. Now I will again take the best option. The best option is this 1 comma 1 comma 0, because the time is 1 and the x and y coordinate is 1 and the y coordinate is 0. Row is 1 and column is 0. So I'm reaching here. From this point I cannot move up because that is already traversed. I will try to move to the right hand side. Yes, it is possible, because initially only we had checked for the blocking condition. So yes, it is possible. What is the time difference? It is time t equals to 1 and this is 8. So the time difference is an odd number, 7. So in an odd case, we know that I can waste 6 units of time by moving back and forth again and again, and then I can make a one size jump to reach to this cell. So that means if the gap in time is an odd number, then I will just add that thing, right? So at this point I can reach to this index 1 comma 1 and time t equals to 1 plus 7. That means it will be 8, isn't it? And I will mark it as true. By the way, I had to also mark this 1 0 as true. I just missed it out. Now I will be trying to make a down call. Can I make this? I mean, definitely, or you can always make this call. Now, but then you have to calculate the time. Time difference is odd. 1 minus 4 is minus 3. You can take the absolute value, it is odd, right? So you just add this value, whatever is the difference, and you make this time equals to 4 and I can reach to this cell. So you mark it as true and push it into the heap. So if you push it, the cost is 4, which is time 4, and coordinate is 2 comma 0. So now we have 3 nodes here, right? The next node which you pop out, it will be the minimum cost node. So that will be 3 comma 0 comma 1. So let's pop out this. This node will be popped out, and here the time is equals to 3. From here you cannot go up, you can go right. What is the gap between this 3 and 5? It is an even number. So take the gap and add plus 1 to it, because this even number will be wasted by moving back and forth, and then plus 1 for the jump, right? So here you can reach at time t equals to 6, the gap plus 1, right? 5 minus 3, which is 2 plus 1. So 3 plus 3 will be 6. So you can reach here at time 6 at coordinate 0 comma 2, and I will be marking it as true. Okay. Can I make a down call? Well, this is already visited, so I will not try it again. Can you make a left call? No, this is already visited, so leave it. After this, let's take out our best option. So this is 420. 420 is this one. 20 is the coordinate, right? From here I will not move up because it is already visited. I'll try to move right. Well, the right value is lower, so I can just make a plus 1 jump to it, and at time t equals to 5, I can reach to index 2 comma 1 and mark it as true. I cannot move down and left, so this is done. The next best option, we have only 3 options: 811, 602 and 521. So 521 will be taken out because 5 is the minimum cost. So 21 is the index. From here I cannot move up, it is already visited. I can move right. You see that this timer itself is greater than equals to this value, so I can just make a plus 1 jump and make a jump of 2 times 6, and then I will be reaching to index 2 comma 2 and mark it as true. Okay, that is done. I cannot make a down call, I cannot make a left call, so this is done. Next option, 602 will be popped out because by default the heap will be comparing the cost. If the cost is same, then they'll be comparing with the second value by default. Okay, so 602 is taken out. So in this case, from 602, here the time is 6. I cannot make an up call, I cannot make a right call, I can make a down call, and I can immediately make it at cost plus 1 because this timer is 6 and requirement is 6 only, right? So 6 plus 1, here time will be 7. So I can push 7 and the index 1 comma 2 there. Okay, I cannot make a left call, it is already done. So the next best option is 622. When you take it out, you will check that, okay, 22 is the one where I needed to go, and this is the destination node. So whatever cost you popped out is your answer. So in this case, the minimum cost path is equals to time equals to 6. Fine. So I hope you have understood the entire dry run using the Dijkstra algorithm. Now for this entire process, the time complexity, as you know, will be total number of items mn multiplied by log of mn, because all these items could be in the heap. And the space complexity is order of mn, because we have taken a visited array of that size, and also a min heap can also grow to that size, so 2 times of that will be the same as mn, right? Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this code, we are given the grid, and I have taken a 5 size integer array which will help us in making all the 4 directional calls. As you know, as I had explained in the previous video, which I sent you as the prerequisite to watch, 3341 and 3342. Then you have the size of the rows and columns. Then I will be checking if it is possible to actually make a move from index 00. If it is not possible, then just return -1. Otherwise, if you can make at least one move from this starting point, then it will always be possible to reach to the end index, right? Because we know that we can pass time by moving back and forth, isn't it? So I'll take a visited array, I'll take the min heap, and then I'll take the min heaps values as the time, comma, xy coordinate. So these are the 3 values I have taken. I'll mark the initial node as visited, and I will push that node into the heap as well, and then I will process the heap. So in the heap, as I had explained, we will be taking out the top of the heap, which is the minimum cost best greedy option, and then I'm finding what is the time x and y coordinate, and then finding if the xy coordinate is matching our destination. If it is matching, then return the time as the min cost to reach there, right? If it is not the destination node, then we will be trying to make all the 4 directional calls. First, I will be checking for the validity, is it out of bound or inside bound, and then I will be checking if it is visited or not visited. Now, if all of these conditions are passed, then we will be making this node as visited, and then I will be calculating what should be the new time. So if the time is currently t, then if you make a jump of +1 size, it will become 1 plus t, right? So that is the new time. Now I'll check if the new time is actually smaller than the grid time, because if you are at some position with, let's say, time t equals to 5, and if you are trying to jump to the next cell which was demanding 8, then can you make a +1 size jump and reach there? So 1 plus 5 is still less than 8, so you cannot make a direct jump. And in that kind of scenario, if you cannot make the direct jump, then I have to see the condition, what is the difference, if the difference is odd or even. If the difference is odd, like between 5 and 8, then just assign this to 8 itself, and this will be the time when you reach here, because you will waste a back and forth timer of +2 +2 +2, the number of times you move back and forth, right? And then you will make finally a +1 size. So this gap size odd can be covered, okay? Otherwise, if the gap was even, like let's say the time was 4, then you will have to take one extra time, because 8 minus 4 is 4. So 4 units of time will be wasted by moving back and forth 2 times, and then a +1's time will be taken. So definitely your time is going to be 9 minimum, right? So that is why I'm checking if the gap is odd. If the gap is odd, assign the same time as it is, that means 8. And if it is even, then you add one number, because you will be wasting all the even time in just moving back and forth, okay? If, however, your time was, let's say, 5, and you are trying to jump to a cell with value 2 or anything which is less than equals to 5 or 6, then you will just be pushing the time, new time. That means even if it was 6 or anything less than equals to 6, then you can make a direct jump to this value, and with the time 6 simply, right? Whatever new time we had calculated. So this is the entire trick of the problem, and if I can find the answer, I will definitely send it. Otherwise, I'll return -1. So this case will not hit for this problem. If it is -1, it will be captured right in the beginning, okay? So I hope you are able to understand it. If you still have any doubt, then feel free to comment below, and I'll try to help you as soon as possible. Like and share our video, and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.